Hello everybody, I am Terry Chen from Group 6. This is our Challenge 1 Oreo presentation. My fellow group mates are Andrew Hoang and Wenpeng Wang. So our mission is to create a system that will continuously measure temperature at 5 different locations in the room and report these values to a central station. And the central station should report the recent temperature values from each thermometer along with the current average temperature in the room. So the design concept is to link all of the XBs in the same mesh with a coordinator that is linked to the computer, and the router XBs are individually linked to an Arduino that measures temperature. And the Arduino circuit is built around a thermistor and resistor as a voltage divider circuit. And the voltage measured between the thermistor is then translated into the temperature by using the following code. And then the sensor will then send the temperature data to the coordinator. The data received from the coordinator and then is processed in Node.js to calculate the average temperature and show the individual temperatures of all sensors. So our schematic of the JavaScript code is based on the different time intervals from different sensors. Since they're all different, so it is hard to capture a specific temperature data from all of the individual sensors. So what we have is to have a floating average of each sensor. Therefore, the average temperature of the room can be calculated from the floating average of each one of the sensors. So while designing our network, we had encountered several challenges. The first challenge we encountered was a problem between the XP communications. We set up the pin ID, but they are still not communicating with each other. So what we did was we found out we not only need to reset the pin ID, but also the operating pin ID and operation channel. So the second challenge we had is we need to find a way to differentiate the different readings from each sensor. So what we did was to create an ID for each Arduino, each sensor, and the code in the Node.js will then pick them up and divide them. The ID is generated in the Arduino code randomly from 1 to 300, and this range of random numbers can be changed accordingly to the number of sensors we have. So as we can see in the code here, the base will then divide them and output it as separate sensor datas. So the third challenge we encounter is to find a way to enable the features of adding and dropping devices. So we resolve that by adding a heartbeat signal to each sensor. So if the base doesn't get a heartbeat signal from any sensor within 5 seconds, then this device is considered dropped. So this is a photo of our coordinator XP and our router XP. So we can see that we have resistors and thermistors attached to the Arduino, and then all the data will then send to the coordinator XP, which will later be computed in the Node.js code. So this is a demo of our setup. So you can see that we have 4 Arduinos set up, and then this is our result. So right now we have 4 sensors and then 4 readings. So when I unplug one, after 5 seconds, the number of sensors will then drop to 3. And then if I plug in a new sensor, then the number of sensors will then go back to 4 again. So this is the interface of our system. So we can see that we have the current temperature in degrees Fahrenheit, and we also have the number of sensors operational in the system. And also the active sensors are listed down there. Take note that there's an ID number in front of each one. So that is the ID number of each sensor that is generated randomly. And so this is our presentation for Challenge 1, and if you have any questions regarding the technical issues or anything, feel free to ask. Thank you.